Madam Aduma, good morning.
Hello, good morning, Doc.
Yeah, hope you are doing good.
Yes, by God's grace.
Okay,
Please, your end.
okay, we thank God. Yeah, we are also doing good.
Thank God.
Good. Emmanuel, Emma Cosrep, do you have all your people on board or some are here to join?
Doc, please, they are joining. I've posted
They
it
are
on the
joining.
page. Yes,
And
please.
we don't have half of your members. So we'll give them some few minutes and see how it goes.
Yes, please.
Then we can start. So how many minutes do you suggest for your people?
Doc, 5.
Okay, so 5 minutes. After 5 minutes, we are starting our lesson for today.
5 minutes since it's 11:55. Please.
Okay, so I think we can now start the lesson. Good afternoon to you once again.
Good afternoon.
Good afternoon, Steve.
And we hope the grace is sufficient to you all.
Yes, please.
Good. My New Year gifts, I'll come for it. Okay, so we've set the slides with you ahead of time, and we hope you have had time to go through the slides. So for the Unit 3, it is on descriptive and inferential statistics. That is where we are starting from. So we've looked at what statistics is all about. We've looked at the terminologies as used in statistics and probability. We've also looked at how we can organize our data after we have embarked on a statistical journey. That we have decided that after we have decided that we will collect data and then try to analyze that data and then interpret the data that we have, the result of the data that we have, and then finally do some reporting of or do some presentation for the findings that we've come out with. Today, we are privileged to look at the major types of statistics that we have. So if we talk about statistics, we can also say that we have descriptive and inferential statistics. So these concepts are concepts that you cannot do away with as far as your postgraduate or your graduate education is concerned. You know, once you decide to collect data and then you do some analysis of that data and do some interpretations for the result that you are getting, simple question that they may ask you or simple observation that could be made about your data you have collected and organized could be that, oh, your data is just descriptive or your data is mainly descriptive. So how do you get to talk about some trend analysis? Why didn't you run some inferential statistics to see whether there are some whether you can do some comparison, whether you can do some trend analysis and so forth. So it is very important that we look at both descriptive and inferential statistics. But before we go into these two major concepts, we want to go the highway. That is, we want to use the Google Scholar to find out the major differences between descriptive and inferential statistics with illustrative examples in mathematics education. So major differences between descriptive and inferential statistics with illustrative examples in mathematics education. Is the task clear? Can you hear me? Is the task clear?
Yes, please.
And so you have 10 minutes to do that. And then when you come back, one of you should chair the session. I think Emmanuel, the course rep, can chair the
Sir.
session.
Sir,
Yeah,
please,
Iman.
I just rejoined. Please, the task again.
Yeah, you have to find the major differences. You have to explore the major differences between descriptive and inferential statistics with illustrative examples in mathematics education.
Yes, please.
And if possible, answer the question, why do we have to care about descriptive and inferential statistics in mathematics education? Why? Why do we have to care at all about these two concepts in mathematics education? So that is the assignment for you. They have 10 minutes to do it, and then you come back and then you take another 10 to 15 minutes to brainstorm with them with illustrative examples. Then we can move on.
Yes, please.
All right. So if the task is clear, then I'm handing over the mic to you. Then you and your colleagues, you work on the task for the next 10 minutes, and then you come and brainstorm with them for the next 10 minutes. And then after that, you hand over the mic. Is the task clear?
Yes, please.
All right, thank you.
Okay, guys, so we can do our search now on descriptive and inferential statistics. Right. Hello, guys. So I think time is up. So please, if you have gotten something, you can raise your hand so that I can call you. Hello. Please, am I coming through? Hello, guys.
Yeah, we can hear
Yeah,
you.
yeah,
Can hear
we
you.
can hear you. We can hear
Can
you.
hear you.
Okay.
Yes,
So
that we are
please,
still.
if you have something, you can raise your hand so that I can call you.
Okay.
Okay, so we will start with descriptive statistics. Please, if you have gotten anything. Okay, Isa Karim, please you can talk. Isa Karim. Yes, please. Please,
Yes. Uh, Under descriptive statistics,
okay.
we are simply saying that these are methods that we use to organize, summarize, and present data in a meaningful way using number tables and then graphs.
Okay.
For example, a teacher calculates the average score, the highest score, and then the lowest score of students in a class test.
Okay.
These are descriptive. In the other way, when you come to the inferential aspect too, we are saying that there are methods that we use to draw conclusions or make predictions about a population based on data collected from a sample.
All right.
Yes, going to the real life situation, we are saying that a school survey, 50 students, like in a survey of 50 students in a particular school, we want to know the favorite subjects and the uses of the results to predict the preference of all students in the school. These are
Okay.
basically what I have about inferential and descriptive. Thank you.
Okay. Thank you very much, Isa. All right. Please, Abubakar, please you can talk.
Yes,
Hello, Arthur.
hello,
Arthur Abubakar.
hello, hello.
Yes, please. Please, you can bring in your
This
submission.
speaking is also a matter of need to summarize the organization to make it more meaningful and economic.
Oh, please, we can't hear you. We can't hear you.
It's a method that we use to summarize and organize the data to make it more meaningful or understandable. It doesn't look at the whole the data, but
Okay.
it gives a brief discussion on how the whole thing looks like by looking at the average and the mean, using the mean and median and other and the mean and median and others to describe how the entire data looks like. That's my understanding on that. Thank you.
Okay. Thank you very much, Abubakar. All right. Yes, Francis. Francis, please, you can talk.
Okay, please, can I be heard?
Yes, please, you can be heard.
Okay, so with the descriptive statistics, I also discovered that it's a branch of statistics which deals with the organization, summarizing and then presenting data in a meaningful way without making conclusions beyond the data that we have collected. And so after organizing, we don't make any conclusion based on the data that we have used. We have organized. And some of the tools that we make use of is the mean, the median, and then the mode. But then with the inferential statistics, that one deals with sampling data to make predictions or generalization. That one, based on the data that we have gotten, we can make a conclusion. For instance, we can say in mathematics, we can determine the relationship between the study time and the mathematics performance. That is, if we are able to know that students use this number of time to study, we can, based on that, to conclude that based on that data, students' performance in mathematics may increase or on the other way around. That's what I also discovered. Thank you.
Okay, thank you very much, Francis. Yes, please, any other? I think we have 5 minutes.
Yes, I just want to come in. Yes, sir. Hello. Hello. Hello.
Okay. So
Hello.
why are we not contributing to?
I just
Why are we not contributing? Eh? Or you want us to mention your name?
Please, I just want to come in.
Yeah, you might take over.
Docs, there is someone who wants to talk. Isa.
Yes.
Isa, you can talk.
Want us to take note of this. There's just just a tip of this that I want us to have. In equation where we see calculate or summarize or find the average of this. This one simple is telling us that we are going under descriptive statistics. In a situation where you see a question like predict, estimate, conclude, then that is inferential. So I just want us to have notice of this, and so that when we see questions of this nature, that talks about calculate, that talks about summarize or find the average of this, it is telling us that we are going into descriptive statistics. And when we have questions like predict, estimate, or conclude, then that has to do with inferential. I want us to have a note of this. Thank you very much.
Yes, I want to also come in with my submissions.
Yeah, Michael, you can talk.
Okay. So what I also found out is that descriptive statistics deals with organizing, summarizing, and presenting data in a meaningful way. And it moves on to say that it answers the question, what does the data show? Then the common tools that the descriptive deals with are the mean, the median, the mode, the range, the standard deviation, and the rest. And when you talk about the inferential, it says that it involves using data from a sample to make conclusions or predictions about a larger population. And it answers the question, what can we infer or conclude beyond the data?
Okay. Thank you very much, Michael. All right, so we have 2 minutes. Let me summarize what we got. So we were to differentiate between descriptive statistics and then inferential statistics. And from our research, we found that descriptive statistics, they are methods that we use to organize, summarize, and then present data in a meaningful way. But it doesn't go beyond the data. So the main question there is, what does the data say? So we are not going beyond the data. We are not using it to make any predictions. And some of the methods that we normally use in calculating the mean or the average, the median, the mode, range, sometimes to use tables and then sometimes to bars. I think one of the descriptive ways that we normally use is the bars, the bar graph, and then the rest. And then when we come to the inferential statistics, we use data from a sample. So if we have a particular population, we get a sample, and then based on the sample, we make predictions, generalizations, or decisions about that particular population using the sample. And then some of the prominent prominent methods here in getting the probability, and then also we have sampling. Then I found something called hypothesis testing, and then confidence intervals. Then we have correlation and then regression as well. And then in the inferential, we are trying to decide what we can conclude from the data that we have gotten. So the descriptive tells what does the data say. We don't go beyond the data. But when it comes to the inferential, we are making inference on the data that we have gotten. So we are making conclusions as well. And then when it comes to it's the importance of descriptive and then inferential statistics in education, I found that it helps to make proper interpretation of data. So when maybe class calls and the rest, or you want to find out what the subject that the students really like one of our colleagues mentioned, it helps us to make proper interpretation of data. And then there is fair assessment and policy decisions, especially when it comes to censors, when it comes to even voting and the rest. It helps us to make. And then developing critical thinking. It helps us to develop critical thinking. And then when it comes to research and then educational improvements to descriptive and inferential statistics help us a lot there as well in education. All right. So guys, thank you very much for your submission. I'll hand over to Doc now. All right. So Doc, please, you can continue from here. Thank you. Hello, Doc.
Anna, what were the major things that you discussed?
Okay, so we discussed the differences between descriptive and then inferential statistics. And we realized that descriptive statistics help us to, if we get a data, we are trying to answer the question, what does the data say? But when it comes to the inferential statistics, we are trying to make conclusions based on the data that we get. Then the descriptive statistics, it doesn't go beyond the data. We are just trying to calculate the mean, the median, mode, range. Sometimes we use bars and then tables to make a description of the data that we've gotten. But when it comes to the inferential statistics, we are normally trying to make predictions into the future. So the data, we get a sample from a particular population, then based on the sample, we make predictions. So we use methods like probability, sampling, then we found hypothesis testing, confidence intervals, and then correlation and regression. We use all these to make predictions based on the data that we've collected. Then with regards to its importance in education, we found that we can make proper interpretation of, it helps us to make proper interpretation of data that we collect. And then it also helps us to make fair assessments in our policy decisions. And then it can also help in developing critical thinking and also in research and educational improvement. Descriptive and inferential statistics help us a lot.
Oh, that's good. Then we are done. If you have discussed all that, then we are done. Isn't it? And you have done the assignment too, right?
Yes, please. We are working on it.
Oh, and you are working on it then?
Yes, please.
When is the deadline?
It's on the 10th.
Okay, that's okay. Yeah, so like you rightly said, you were on points, and that is what exactly.
Hello, Doc.
Yes, Aduma.
Please, can I chip in something?
Okay.
Okay. So please, your assignment. We will need the soft copy that you sent to Doc's email. Then please, when you are coming, you have to bring a hard copy too. On the 10th. We'll be meeting face to face. So yes, please, when you are coming, just print it out and bring it. I'll be collecting it on that day.
Yes,
thank you.
Yes,
I hope that is clear.
Yes, please.
Good. So Hey, did I hear some hand up? I heard some sound, or somebody just joined. Okay,
Yeah, Francis
so
Ajay. Francis Ajay has raised his hand.
okay, Francis.
Yes, please. Doc, please, I asked on the platform as to whether we are writing and scanning to send or we are typing the assignment.
You are supposed to type, but whatever form that you do it, once it's presentable, I think Madam Adma has pleaded on your behalf. Once it is presentable, do you get it? Whatever form you do it and you make sure that we get both the soft and the hard copy, that is fine, okay? All right.
Yeah, so those of you who cannot type now, you can write it neatly and maybe print it out and present it on that day.
What are the soft copy?
The soft copy will be sending it to Doc's email. I've put it on the platform.
Okay. So thank you very much, Madam Aduma, for your additions. Okay, so the inferential and then the descriptive statistics, I think you have said it all. So basically, that is what descriptive statistics stand for, and that's of the inferential statistics. So descriptive statistics, we said that they are powerful. They serve as powerful analytical tools that help us summarize and describe the essential characteristics of data sets. So simply put, the descriptive statistics helps us as statisticians, okay? It helps us to organize, summarize, and then present the data so that it is easy for people to understand, or for our readers to understand what is happening within a given group of learners or data sets. So the descriptive statistics, the data could be about student, or it could be about any given data set that you have and want to talk about. So again, like you clearly said, descriptive statistics are methods used to organize, summarize, and present data so that it is easy to understand what is happening within a given group of learners or data sets. And then you also added that in descriptive statistics, we say we should look for the differences. So in descriptive statistics, descriptive statistics do not make predictions. That data sets do not make predictions or generalization beyond the data collected. Okay, it does not make predictions or generalizations. So once you want to make predictions and generalizations, then it means you are doing inferences. You are trying to make inferences on the population based on your statistics that you are getting from the sample. So you were also asked to talk about examples of give an illustrative example. So for instance, if a math teacher calculates the mean, median, and mode of a class test, if the teacher also go ahead and draw a histogram or a bar graph of learners' marks, if the teacher finds the range or standard deviations of scores, that teacher is purposely doing that to understand how this specific class, or how the students performed, or how the class performed, and how will be described, how do they perform. So you have to describe their performance. How was their performance? How will you answer that question? You answer that question by what? Describing their performance, right? So for instance, in describing their performance, you could say that 60% of the learners scored above the average. You could also say that the median mark was maybe 40%, or the students' scores are positively skewed. You may be making some of these descriptions. Once you say positively skewed, negatively skewed, then it gives a fair idea of you are trying to describe their performance, right? Okay, so that is basically that. Then when we come to So we have made mention of the key descriptive statistics that you can talk about. We mentioned the mean, which is the common one. We mentioned median, mode, variance, standard deviation, range, and skewness. What we are trying to say is that mean, median, mode, variance, standard deviation, range, and skewness are descriptive statistics. They try to describe the performance of, or they try to describe a data set. Okay, they try to describe the nature of a data set. Unlike the inferential statistics, which make predictions about larger population based on the sample data, descriptive statistics focus solely on describing the data we have in front of us. So descriptive statistics.
Sir, please, the
Yes.
slides are not moving.
No, yes, the slides are not moving because I have not moved.
Okay, thank you.
Why do you want to move me when I have not?
I thought it's my network. Sorry, Doc.
No. It's not moving. Okay.
Okay, thank you very much.
But you can see, isn't it?
Yes,
you
I
can see, right?
Yes, please. Yes,
and
please.
then thank God you can see. I've even made it a bit larger for you. Okay.
Yes,
good.
Please. Thank you.
Good. So we are talking about descriptive statistics, and that is what we were talking about. That for descriptive statistics, the focus is on summarizing and describing the characteristics of a data set, or essential characteristics of a data set. And these essential characteristics of data set could be the mean of the your student performance, the median of your student scores, the mode of your student scores, the variance, standard deviation, range, and skewness. So these are the key examples of descriptive statistics. And this is why when you collect your data, when you start your project work, you do project. Oh, no, I think people are not doing project work. But when you start your master's and you are doing your thesis, you collect data, you analyze that data, and then you do some description of, you describe the data that you have. If it's about the student performance, you describe. After describing, you try as much as possible also to make some inferences, because remember, you collected the data from a sample that represented a sample of a population. So you now have to use that sample data to make inferences or generalizations for the population that you selected a sample from. Once you are making those inferences, then you have gone beyond descriptive statistics. You are now talking about inferential statistics. So the fundamental distinction between descriptive statistics and inferential statistics lies in how we approach the data analysis and how we interpret our findings. Okay, how we approach the data analysis and how we interpret our findings. That will tell us to know whether the person is describing the nature of the data set, or the person is making inferences for the population based on the sample data. And when we talk about the nature of analysis, or the approach data and the approach that we use. For instance, in doing inferential statistics, we may be using some inferential tools, data analysis tools like the ANOVA, MANOVA, mention them, regression analysis, correlation analysis, pair sample t-test, independent sample t-test. You may also be mentioning the chi-square and so forth. So those are examples of what inferential statistics. But look at the descriptive statistics. We mentioned what? The mean, median, mode, variance, standard deviation, range, and skewness. So practical example, consider calculating the average test score of 85% for a class of 30 students. This is descriptive because it tells us about this specific class. It tells us about that particular class that you calculated their average score of the 85%. Now, predicting that the next year's students would also get an average score of 85% will be an inferential statistics. So predicting that the next year's students are also likely to get 85%, 95% average score will be an inferential statistics. Now we come to the foundation of data analysis. Every quantitative study begins with descriptive statistics. Before we can make predictions, test hypotheses, or draw conclusions about populations, we must first understand what our data looks like. Descriptive statistics provide this essential foundation, offering a clear snapshot of data set characteristics and helping us identify patterns, anomalies, and areas requiring further investigation. This is very clear. You see, I find it quite interesting or intriguing when some of the students come to do a presentation on their thesis and they go straight to the inferential statistics without talking about the descriptive statistics. When you do that, the simple question they will be asking you was that, so what was their mean performance? Because when you are doing the inferential statistics, you might not talk about their mean performance. Please, are you following what we are saying here?
Yes, sir.
So if you want, for instance, you want to explore the gender differences between male and female students' performance in, let's say, geometry, and then you go straight away using the independent sample t-test after you have tested and your data met the normality assumptions or met the, how do you call it, the parametric assumptions. We have parametric and non-parametric. So after it has met all the parametric assumptions, and then you go ahead and use the parametric tool, which one of the parametric tool, which is the independent sample t-test. You are right, but you see, somebody would ask you, what was the mean performance of the male students in geometry? What was the mean performance of the female students in geometry? What was their respective standard deviations? Because if I see the mean, it will give me a fair idea that if the male student had maybe, let's say, 30 out of, let's say, 70, and the female student had maybe, let's say, 20 out of 70, it is really likely that at the end, nobody should tell you that there will be a significant difference between the male and the female students' performance in geometry. But if the mean for both groups, one is 29 and the other is, let's say, 30, and then you come and report that that straight away without the mean, and then you report that, oh, there was a statistically significant difference between male and female student performance in geometry. We may not understand, so we'll ask you, what was the mean score for the male? What was the mean score for their counterpart female? What was their respective standard deviation? Once we get that, we get that descriptive statistics. It will give us a fair idea, the foundation or the basis for us to believe what you are saying or to shoot what you are saying. Please, are you following?
Yes, please.
So it is important that for your viewers and readers to follow or understand the inferential statistics that you are talking about, then let the descriptive statistics form the basis for your inference. So present the descriptive statistics and say that you want to find out whether these descriptive statistics that we are seeing, whether indeed there will be a significant difference between the mean performance of male and female students. Then so go ahead and yes, so go ahead and tell us your findings. So it was found out that there was no statistically significant difference between male and female student performance in geometry, even though the male student seemed to have outperformed their female counterpart a little bit. Then once we see the mean and the standard deviations, we will not doubt what you are saying. And if we see the mean and the standard deviation too, and it created a different impression, we will tell you and we'll go further and we'll catch you. And we will arrest you. Or you don't want to be arrested. I hope we are together.
Yes, we are together.
Okay, so in talking about the descriptive statistics, we mentioned mean, median, mode, range, standard deviation, and so forth. Now, we have out of those statistics that we mentioned, we have the group that we call measures of central tendency. So if we want to talk about the statistics that can be categorized under central tendencies, then we mention mean, median, and mode. Why are we saying that the mean and median and the mode? Why are we describing mean, median, and mode as measures of central tendency? Why? Can any of you tell us why are mean, standard deviation, and mode described as measures of central tendency? Find out and raise your hand. But Aduma, do you see any hand up?
No, Doc. Please, no one has raised their hand.
Did you hear the assignment that I give you? I asked you to find out why mean, median, and mode are described as measures of central tendency. And I said, when you are ready with your finding, raise your hand and let's call you. We need about few of you to talk to that issue, and then we move on. Today we can close early, depending on how you people would approach the lesson.
No, please, my hand is up.
Yeah, you can speak. I thought Madam Aduma will see you. That's why you speak.
Sorry.
They are because they summarize a data set using a single central value.
Okay, so they summarize a data set using a single central value.
Yeah.
Okay, that's good. Any other?
Hello, Doc.
Yes, Emmanuel.
Hello, you can talk.
Yes, please. It says that mean, median, and mode are called measures of central tendency because they each describe a central or typical value around which a set of data is clustered.
Good. So, simple put, the mean, median, and mode, we use them to represent a data set. You see, when your health teacher wants to find out about your student performance, you ask you what was their average performance, what was their mean performance. Average score is their mean performance, isn't it?
Yes, please.
So the head teacher will not ask you about everybody's performance unless you want to go into specific students' performance. Otherwise, you ask you, what was the mean performance of your student? What was their modal score? What was their median score? Once the head teacher gets a fair idea about this, he knows he could tell the picture of the student performance, because those single values represent the entire student. Well, all the student scores came together to determine the mean, the median, and the mode. You know, the mean, you need to sum, we'll go into that. You need to find the sum of all the categories, all the values, and you divide it by the number of observations that were added. Then when you go to the median, the middle number, after you have arranged your data set in ascending or descending order. Then we have the mode, the most occurring observation. So the reason why we gave you the assignment is for you to do the calculations outside what we are doing here. Okay, so make sure that you pay attention to the assignment we give you. The assignment we gave you is going to count so much in your exams. Don't say that we didn't say it all. This support, you will not get it anywhere. Praise the Lord.
Hallelujah.
Hallelujah, Lord.
You will never get this support anywhere. So please make sure you all do it. Don't give it to somebody to do it for you. You can ask somebody to help you understand how to do it, but don't let somebody do it for you, because you are digging your grave for failure. That is it. When those questions, similar one comes in the exam, you can't do it. And remember, when we were doing the organization of data, we also mentioned the histogram with unequal interval. Did you remember that?
Yeah, you said something like that.
Good. I thank God he said something like that. You see, prophecies, the way prophecies normally comes, I don't see anything again. Let's move on. Okay, so the first one, which is the mean, is the same as the arithmetic average. So the arithmetic average, that's what we said. Find the sum of all the observations and divide it by the number of observations. You are gone. So, and you know, we have mean for group data, and then we have the mean for on-group data. And I think what you have there, we have both group and on-group. Work on them, especially the on-group. And then when you have been given the assume mean method, how you find the mean, the actual mean using the assume mean method, please. And then how you find the standard deviation of that data set when you have the assume mean. You are using the assume mean method. Please. We are begging you. That's why that task was given to you. So then when we come to the real life examples, you can consider that in economics, where average household income can be misleading when a few billionaires dramatically increase the mean. What we want to say is that mean or the arithmetic average is mostly affected by outliers or extreme values. Okay, they are affected by extreme values. Median is one affected by extreme values. No. Right? Mode 2 is not affected by extreme value. But for the mean, it is affected by extreme values. And a typical example is what we are giving here. Assuming that only few billionaires, there are few billionaires, and you want to calculate the average household income. Then because of the billionaires, it is going to increase the average income of the people a little bit. Or it is also going to, if in terms of the billionaires, is going to reduce their income level. You may think that, oh, they are all not rich, okay? They are not high income, they are not high income earners. But trust me, there are some who are billionaires among them. Like your course rep. You don't say amen.
Amen.
If you are a billionaire,
Amen.
and I have you as part of my this thing, that's why I'm not afraid. Then we come to the median, which is simply the middle value of a data set. How do you find the middle value of a data set? You can only do that when you have arranged the data sets in ascending or descending order. Because it is the middle value, and you have to arrange in either ascending or descending order, whether you have a very big or small value, it doesn't affect the middle number. It's robust to outliers, making it particularly valuable when analyzing skew distributions. Then in real estate, where we want to find a median house prices. Okay, in real estate, median house prices provide a more accurate pictures of the typical home price than the mean. So what are we trying to say? In real estate, you know that there are some of the houses that are low and others too are very high. So if you want to describe the nature of the house, the prices of the houses, those houses or land or whatsoever, I think the best thing is to list all of them, arrange them, and it will tell you that, oh, okay, so this is the highest value, or this is the middle value after, or these are the values that seems to be intriguing, right? Since a few luxury mansions won't distort the median as they would have done to the mean. So like what we have here, look at the picture that we have here. You clearly see that we have the houses. Okay, so they have been arranged nicely. So we can be interested in the middle one to make some description of the nature of all the houses that we have there, right?
Please, Doc, please, the picture didn't come.
We can't see anything.
You can't see anything.
We can't see anything.
When you finish, watch on your slides, you can see.
Yes, please.
Or is it because I maximize it? Can you see now? I've minimized it again. Can you see?
We only have descriptive and inferential statistics on the
so the picture, that's where you have to come for this, face to face. You see, if it's face to face, you will not be saying what you are saying. No, I'm going to draw the houses on my screen for you, okay?
But please, can't you move it? The slides.
No, it's a PDF. It's PDF. You can't add or do anything to it. This is the unique trade. We gave it to you as a, how do you call it, a link. Do you remember? Hello?
Yes, please. Yes, please.
So those of you saying that it's a link, and that's what I'm telling you. I'm even getting into trouble. I want to do something, and you see that I'm mixing the thing. Okay, so please, let's go the way we are going. I beg. Where you see the picture, it means you have to see a picture. Where you don't see the picture, it means you see the picture on your slides. You also have the slides. Don't you have it?
Yes, please.
Have it. We have it.
Or I should draw the house for you. Which
No,
of the house? Okay, like I'll draw.
Yeah.
Then we have the
We have the
median.
high.
So the median, that is what we talk about. And I think the next one is the mode. So the mode is the most occurring word. The most occurring observation, or the observation that occurs most. So that is about the mode. And I think we have a simple examples here. Look at the data set that we have. This one. Can you see? The one I've colored. Can you see?
The slides is not moving. You.
Oh, please.
The slide is not moving, cry.
Yes, please.
Yes, please.
It's interesting, isn't it? Let me see something. Okay, let me see. Is it moving now?
No, sir.
No, please.
No.
Okay. Then maybe the one I have opened a different ones. That's why. So let's see. Is it moving? Is it moving?
Yes, please. Yes, please.
Yes,
Yeah.
yes.
So
Yes.
I've opened 3 different. So that's why. Sorry. Okay. Okay. So this one you can see the picture, right?
Yes, please.
Yes, please.
Okay. Those of you who want to see the house, so that you build one like that for me. Look at the house, the middle one. Look at the middle house. If you're able to build the middle one for me, you go to heaven.
Don't worry.
Can you see the house? Can you see the houses there?
Yes, you can see it.
Yeah, the middle one.
The mode.
So then we were talking about the mood. So you have these data sets. You have these data sets, and you were to find the mode. So what will be the mode?
7.
7. So the mode is 7, right? Okay. The first thing you have to do, if you want to find, no, they say you have to identify the mean, the median, and the mode. So you have talked about the mode. What are the median?
Median.
7.
With the median, we have to arrange it in order.
There's 7. 1, 2,
And so do that. Arrange it in order and tell me.
2, 3, 7, 7, 9.
So it will be 7.
So it will be 7.
So the median will be 7. Okay. Then what about the mean?
The mean 1, 2, 3, 4, 5.
5.6.
Did you do the calculation 14. Or you are telling me the answer here? The answer here is wrong.
14. 17, 19.
You add divide by
20 divided by 5.
Yes. So it's
5
point
something.
It's 5.6.
Okay.
5.6.
Then if that is then that is good. Okay. So after talking about the measures of central tendency, there are other descriptive statistics that we mentioned that we've not considered.
Dispersion.
They are examples of measures of dispersion. Okay. They tell us how the data is spread around the mean. Okay. So they tell us how the data is spread around the mean.
Do you have mean?
So the first
division and variance.
Yes, the first one is the range. And the range, we know how to compute the range, isn't it? The largest observation minus the smaller observation, right? Minus the smallest observation, or the bigger, the bigger minus the smaller, right? So that is that. Then we come to the variance. So the variance is the square of the word, the standard deviation. So in simple term, you subtract the mean from each of the observations, and then you square it. You square each of them. You find the sum of that, and you divide it by n-1. It's n-1 because it's a sample. Okay, because it's a sample. It's not the population. So this is a sample. But in some cases, in a sample, the n minus 1 is when the sample is large enough and it's almost equal to the population, the n minus 1 is approximately equal to the n, right? So we use the n for such calculations. So then the standard deviation is what? The square root of the what? The square root of the
variance.
The square root of the variance. So please do those things yourselves and it will help you. So for instance, we have the data set here and I want you to now take your time and do that. Okay, look at the numbers. You have 5, 7, 7, 10, 12. You have to find the mean and you have to find the standard deviation and the variance. I hope you can do that. Do that and let's see. Don't give me the answers here. If you are done, you raise your hand, okay? Find the mean and then the standard deviations. After that, you find the variance. Use the formula we have given you and let's see if we get the same answer here. Yes, Adama. You can't hear me. Is it? Yes. Okay. Oh, we'll finish. This one, there are not many, isn't it? Okay. Okay, so are the values confirmed? Those values, are they confirmed? Oh,
Dog, we are still computing, dog.
I see. Any confirmation? Oh, hello.
Hello, Doc.
Hey, this just about
Hello,
5
Doc.
numbers. Yes, just about 5 numbers, and you can't find the standard, the variance and the standard deviation. Hey,
I got a standard deviation 30.56.
And the square root of that gives you what? 30.56. And the square root of that, let's see, the standard deviation has 30.56. But that is not what is here. Did you divide it by 4 and see? N minus 1.
Dog.
Yes.
With the sum of the square variance, I had 30.8.
Okay.
Then the variance, I had 6.16.
Okay.
Then heading towards the standard deviation itself, I had 2.7. 2.77.
Okay, 2.77. Okay. Okay, so that's fine. Let's move on. That's fine. Let's move on. Then the next thing is about the skewness and then the normality. So the skewness. So for a normal graph, we expect to see this one. So can you see this one?
Yes, please.
Yes, please.
That is the normal curve. And then under normal circumstances, that's how the normal curve is supposed to look like. So the normal curve is symmetrical. So that's why you can see that we have half over here. We have half. Half of the data set lies at the right, and half also lies at the left. But in cases where we don't have the normal performance of our student, then it will be skewed. So the skewed one, we have skewed to the left and skewed to the right. Okay, when it is skewed to the right, we say it's possibly skewed. Right? Now, what does it mean to say that your student's performance is skewed to the right or skewed to the left? So when it is skewed to the right, that is positively skewed. It means that the mode is less than the median, and the median is less than the mean. Okay, it means that a few large values pull the mean to the right. A few large values, pull the mean to the what? To the right. So for positively skewed data, it simply means that most of your students didn't perform well. Most of your students performed below the average, or they had a low score, okay, as compared to the average. By the negatively skewed one, it means majority of your students had a high score. And it has so many implications. Either the questions were too low, or were too difficult, or the student did not learn. We can make so many inferences from that. So that is that about the positively skewed and the negatively skewed data. So you see that this one, the longer tail is to the right. Can you see it? So this is where we said that it's skewed to the right, positively skewed. And when the longer tail is to the left, we said it is negatively what? Skewed. Please, are you following?
Yes, please.
Then I think these ones, we did them last time, using the graphs to represent the bar chart and then the histogram and so forth. So we'll not talk about them. We did those ones last time. So let me see what is new here. Designing a small study by collecting data and describing which descriptive statistics you like to use and why. And so what it means is that if you are to be given a data, some few data, and then they ask you which descriptive statistics will you use, you should be able to justify why you are using a particular descriptive statistics, or you are representing them using a particular graph. I think this one is something that you can do. Descriptive statistics as foundation. The Bloom's taxonomy. What is the Bloom's taxonomy doing here? It has implication for the kind of questions we set, okay? So when the question, majority of the questions are asking students to create or evaluate, analyze, apply, the students tend to perform low if they are not well prepared. Then where we have questions just ask them to, majority of the questions are on their ability to remember or understand. They tend to perform they may tend to perform high, above the mean. So you have to calculate the variance. This one too, since you're able to do the first one, you can do them. This is the nature of the normal curve. The nature of the normal curve. You see how nice it looks like. Is there any question you want to ask on the Bloom's taxonomy? Yes. Whose hand can we see there? I'm using the full screen.
This is Issa.
Karim.
Yeah, Issa Karim. Ask your question.
Yeah, as sir, heading towards the Bloom's taxonomy, what are some of the likely questions that one may ask when designing or using the Bloom's taxonomy? The likely questions we may use when addressing students with regards to them.
Oh, when these ones, you have to read on them. But for instance, where you ask students to state, if you ask students to state, it means you are just testing their ability to, their comprehension or those are low cognitive questions.
Ability to recall.
Their ability to recall, formless. So if you ask them to state a particular theorem of ask them to state the area, the formula will find the area of a circle. All those ones are, but where you ask them to synchronize or you ask them to analyze, evaluate. So evaluate the following questions. Once you see those, how do you call it, verbs, it tells you that you are using higher order Bloom's taxonomy abilities or questions. Is that okay? So that is what we have here, this one. So go and read on them. Normally, the Bloom's taxonomy don't find itself in statistics. So I don't know why it is here. But however, I think it borders on the kind of assessment task that it normally counts in assessment. It borders on the kind of assessment task that we give to the student, which might make them give us which might end up giving us a picture of either skewed to the left or negatively skewed or possibly skewed where it is skewed to the right. Their performance will be skewed to the right. Okay. We mentioned that when they are skewed to the right, it simply means that majority of them didn't perform well. But when it's skewed to the left, most of them performed above average. And there are a lot of questions we need to ask. What kind of assessment task did we give them? What was the cognitive level of the task? Right? So that is it. But then the Bloom's taxonomy you saw here, this one, they are the new revised Bloom's taxonomy. Okay. The revised new Bloom's taxonomy puts the student ability to create at the apex. But this one, just that it was 10. Okay. The highest is from the down there. The higher level is from the down there. Student ability to create, then it reduces to evaluate, analyze, then apply. As you go up, it reduces the cognitive level of the questions reduces. You can turn it where the remember, understand will now be at the down, with the highest being the create. The revised Bloom's taxonomy is the other way around. The create is up. The next one is evaluate. The next one is analyze. The next one is what? Apply. Then the down there, we have the remember and understand. But this one is just for illustration's sake, and that is why we did it this way. I hope that is clear to you.
Yes, please.
So,
Is somebody say no? Can we move on?
yes, please.
Yes, please.
Okay, so the common mistakes we need to avoid when reporting only mean. Always pair central tendency with dispersion measures. So don't just mention the mean without the standard deviation or the variance. So always make sure you pair. Otherwise, you will not be telling the complete story. So that most often you see students reporting the mean without a standard deviation in some cases. When you do that, it doesn't really tell us how the data is spread around the mean, because that is what the standard deviation tells us. So the spread of the data also add more insight into the interpretation of the data that you have analyzed. Then in assuming normality, check distribution shape before choosing statistics. Okay, you must always check whether your data that you have, your student performance, is normally distributed before you think of either choosing the parametric or non-parametric. If it is normally distributed, if the shape is like, if you draw and the shape is normally distributed, then you can use the parametric data set to be. But if it is skewed to the left or skewed to the right, then you may be interested in something they call kurtosis. Kurtosis. I think Kurto, kurtosis. COSIS also. Yes, kurtosis. and other data analysis that you can use. So these are some of the softwares that we can use in analyzing our data. We have Excel. Excel can help you to find descriptive statistics. Excel can also help you to find the standard deviation. And we also have the SPSS. The SPSS, I have it. The Python, I don't know how to use it, but I know how to use the SPSS and then the Excel. So for the SPSS, you can go beyond the mean standard deviation. You can go beyond the mean standard deviation, the frequency count, the percentages, and do the inferential analysis for your data sets. Now, you must, in calculating for normality, one of the things that we test for is that your sample size should be greater or equal to 30. So if your sample size is less or equal, if your sample size is less than 30, then it means that in terms of sample size, one of the assumption is violated. And that is one of the easiest considerable assumption that your data should be able to meet, so that you say that you are running the normality, you are using the parametric data analysis tools. If that is less than 30, then remember that one of the tests for normality is violated. And then if you also draw the curve, either using the histogram, you can use a histogram, and then you draw the curve on the histogram. If it is not normally distributed and is skewed, then it should also tell you that the data is not normally distributed. And you have to consider a kind of, so the larger the sample size, the fact that we said that the sample size, the fact that we said that your sample size should be greater or equal to 30, one thing you must note is that it depends on your population. So the bigger your samples, the larger your sample size, the more accurate it is in estimating or representing the population. So that is what you have to learn from here. Then when we come to the inferential statistics, they are used to make predictions about the population, test hypotheses, and draw conclusions. It answers questions like, what can we conclude beyond our sample? What can we conclude beyond the number of the performance of peoples in Cape Coast metropolis? What can we conclude beyond the performance of peoples in Cape Coast metropolis that we have collected the data on? Then to do that, what can we conclude beyond? Then we can think about the use of t-tests to see whether there is a difference between male and female people's performance, which we can generalize on the population. Then we can also do other sort of in-context analysis to throw more light on the data set that we have. We can run regression to see the relationship between the male and female people's performance, or whether their performance in the previous test could predict their performance in the exams. All those things can. Then the confidence interval. So in inferential statistics, you must always have, because you are making a prediction, your prediction should be confined within an interval, which we call the confidence interval. If your confidence interval is 95%, it means you are allowing 5% as error margin. So 5%. You are saying that you are 95% sure that the prediction you are doing is right. And if it is 90, it means that you are allowing 10% for saying that, oh, maybe the answer, my prediction is just based on the chance. But 90% accurate that the male, there is no significant difference between male and female people's performance in fractions. So the confidence interval is also there, and I think we are going to visit the confidence interval in one of the units again. Then we come to the percentile. So descriptive measures, we have the coefficient of variation. You can find the coefficient of variation. Yes, whose hand is up? Am I hearing some sounds?
Yes, please. Edward.
Yes, Edward. Yes, Edward. Edward, can I hear from you? Can we hear from you? Edward, talk. Okay, Edward is fine.
Let's continue.
All right, so we have, when we come to the descriptive measures, we can also measure the coefficient of variation. With the coefficient of variation, is simply the standard deviation divided by the mean times 100%. So that is this one, because it's PDF, I don't know. You see, it's PDF, so I'm not able to write on it. And it's a link. We are using a link, so it means, yeah, so it is the standard deviation, the ratio of the standard deviation to the mean times 100%. So standard deviation of your data set divided by the mean for that same data set times 100%. Whatever score you get will be the coefficient of variation. And that enables the variability across, it describes the variability across the data set with different units or scales. Then we can also report the percentiles or the quartiles. So remember, we have in the previous discussion, we talked about the Q3, Q1. The interquartile range, we say Q3 minus Q1. The percentiles, we also mentioned, we have the 50th percentile, we have the 75th percentile, all those ones. The 75th percentile is just like it's not the same as the upper quarter. Let's see, 75 divided by.
Yes.
So that is it. So those are some of the things you also have to take into consideration when you are revising. So some of these ones, we have discussed them already. So let me see what is there that we haven't discussed. Resources for continuing learning. Textbooks for these ones. Okay. So any questions so far on the descriptive and then the inferential statistics? We want to move to the unit 4 where we look at permutation. Can we move to? Okay, so yes, if you look at the nature of these slides, you are not doing very rigorous calculations, right? Let me see if these ones I can. Oh, okay. Let me see if my pen can write. I've gotten some. Oh, okay, good. Okay, so fine. So now let's go to the unit 4. Let me show the unit 4. I think that one I can write. Okay, so welcome to the unit 4. The unit 4 is on counting system, that is permutation and combination. These are also secondary school concepts that you already know. And therefore, when it comes to permutation, please, can you see the slides?
Yes, please.
Yes, Doc.
Okay. So when we come to permutation and combination, they are part of the way we count. So we in some books they call it counting. Okay, counting. So when we are counting, sometimes we order the way we do our counting, or when we are arranging objects, and then sometimes we just collect objects without organizing them. We don't care about the position, and these are some of the things that matters when it comes to permutation and combination. So in this unit, we'll be introducing ourselves to the concept that have been mentioned earlier, that is permutations and combinations. I want you at this point, to make your little observations, your little research on what goes into permutation. Okay. So when we talk about permutation, what is it? We are talking about permutation in mathematics or in statistics. So we can do that. What is permutation? If the spelling is wrong, forgive me. In mathematics, right? So we can write small. Okay. Yes. So let's look at that, and then in the same case we look at combination. Combination, either in maths or statistics, wherever that will get the best information. Okay, so I think some hands are up, right? But I cannot see those hands.
So it's me.
Oh, where's my able Madam Aduma? Anof.
Doc, please, I'm here.
And when you see the hands,
Anof's hand is up.
Okay, so Anof.
Yes, Doc.
Yes, so yes, now tell us your findings on permutation and then combination. What are the differences between permutation and combination?
So there are topics in combinatorics, a branch of mathematics that deals with counting and arranging objects.
Yeah, enough. You kill us. They are topics in what?
Combinatorics.
Please pronounce the word combinatorics. Pronounce the word. Student,
combinatorics.
Pronounce the word combinatorics.
Yes,
okay,
please.
Go on.
A branch of mathematics that deals with counting and arranging objects.
Good.
It says that permutation is an arrangement of objects where order matters. So with combination, permutation, the order matters, but with combination, the order does not matter.
Okay.
Then there is a formula here. NPR equals n factorial over n minus r factorial.
The formula is what?
NPR.
Okay, n permutation r is equal to
n factorial over n minus r factorial.
Over n minus r all factorial.
Yes, please.
Okay.
And then the combination is NCR.
The combination
NCR. Yes, please.
So combination we have order does not matter, right?
Yes, please. Yes, please.
Okay, order does not matter. Okay. Then you said the formula is n combination r is equal to
n factorial
divided by n minus r all factorial, then r factorial. Okay.
Yes.
So these are the two major formulas that we'll be using. So for the first one, we said that order is important. And then the second one, order is not important. So these are the major things we want to do today. But when you go to the secondary school, you can get, let me see, there's a book here. Oh, my pen has just fell down. Okay, it's still writing. So let me get something, let me show you something from this book. Permutation, combination, good. So you can get a question like this. In the secondary school, I don't know about this, but because I have not seen any rigorous. So you can be given a problem like this. That is simplifying. So maybe you can take note of the following. Oh. My pen, the ink is too much, but don't worry. I don't. Okay, so you can be given a problem like this. N plus 2 divided by n factorial. Oh, where have they all gone to? So you can have n plus 2 divided by n factorial. When I write, the thing goes to. Praise the Lord. So maybe I can say them. You can be asked to. I don't know why. Where's my pen? Okay, good. I think I'm back. Let me pick my pen. So you can be asked to do the following. That's n plus 2 divided by n factorial. I think I have to clean something. Hey. So you see this one. You can be asked to simplify this. Please, can you see this question?
Yes, please.
Yes,
You
sir.
can. There is another one, which is n plus 1 all factorial. Before you come for the face-to-face, make sure you do it. Plus n plus 3 all factorial, this way. And lastly, you can have this one. That is n factorial divided by n plus 3 all factorial. So make sure that all these examples, you work on them before coming. Is that okay?
Yes, please.
There's another popular one. Let me add that one because I don't know what is going to happen. So you have n minus 1 all factorial divided by n plus 3 all factorial. So all these are popular ones. You have to use your principle of factorial to do that. Remember, when we have 5 factorial, it is the same as 5 times 4 times 3 times 2 times 1. If times 0 factorial. But 0 factorial is the same as what? 0 factorial is the same as what? 1.
1.
So that's why usually we don't bring the times the 0 factorial. So we just do it 5 factorial is equal to 5 times 4 times 3 times 2 times 1. Because the 0 factorial is the same as 1. Okay. So the same principle is what we are supposed to use in doing these simplifications. Okay, so can we move on?
Yes, sir.
So we come to the definition of permutations, and we are saying that permutations refers to the different ways in which a set of objects can be arranged, taking into account the order in which they are arranged. So if you look at what we have here, they have been arranged. So you see in terms of colors, they have arranged them. That's what we are talking about. But we'll see the mathematics in this very soon. Is the slides moving?
Yes, sir.
So
Yes,
you
please.
can see that these books have been arranged in a shelf. Can you see the shelf? The books in the shelf?
Yes, please.
The books have been arranged in the shelves, and they have been arranged in such a way that it comes with some criteria. So, for instance, if we have 5 factorial, like what I mentioned, the 5 factorial will tell you that if you have 5 books and you are arranging them in a shelf, you can arrange them in 5 different ways. Where the position, or if you have 5 people and they are to sit on a chair, the first person can sit 5 different ways. The first person can sit at any of the 5 positions. Okay. The next person, after the first person has sat can sit 5 ways. The next person can sit 4 ways. The next person can also sit 3 ways. The second but last person can sit 2 ways. The last person has only one option. That's why it's 1 times 1, because it has only 1. So if you have 5 people and you are arranging them on a chair, then it means that that 5 people can sit 5 different ways. So that will be 5 . So that is where we have the 5 factorial. You are arranging 5 objects in a 5 books in a shelf. So the 5 books can be arranged 5 factorial or 5 ways, and that will be 5 times 4 times 3 times 2 times 1. And you are getting what? 120 what? Ways. You have to add ways. So what it means is that they can be arranged in 120 different ways. A total of 120 different ways. The first person can sit 5 different ways. The next person can sit 4 different ways. So usually we use something like this, like a bench. So you have the bench. So you divide this into 5. 1, 2, 3, 4. Is this 6 now? 1, 2, 3, 4, 5, 6. So let's say that is 6. We are arranging 6 people. So the first person can sit 6 ways. The next person can sit 5 ways. Okay. The next can sit 4, 3, 2, 1. So if you want to find out the total number of ways that we can arrange the 6 people on a bench, then the total ways, okay, will be equal to the 6 times 5 times 4 times 3 times 2 times 1. You must do this, and then which will be equal to 120. Even though, hey, no, this one will be 120 times 6 will be what? 720. Good. So that will be 720. 720 ways. Yes. So this is how the illustrations you may be seeing when it comes to the permutation. Here you see that order is important. So normally we can write A, the first person, B, C, D, E, F. So these are the 6 people. So A can sit 6 different ways. If A comes, he has 6 different options that he or she can sit. Then the next person, which is B, can sit 5 different ways on this bench, the remaining bench. Then the C can sit 4 different ways. The D can sit 3 different ways because there are 3 spaces left. They can choose to sit here, there, or there. If the 4th person sits here, then the next person, which is the E, or the 5th person, can sit 2 different ways. Then the last person can sit only one way. Only one way. So that is giving us 720 ways. Now, if we have the 3 numbers, so now I want you to arrange these 3 numbers where order is important. You are arranging 1, 2, and 3. So you have 1, 2, 3. We want to arrange them where order is important. Can you do that for me? How many different ways can we do that?
6, please.
6. So so that is 3 factorial. So 3 times 2 times 1. Would that be 6?
Yes, please.
Okay, so that will be 6 ways. But can we try that? So let's see what we have here. It has been done. So let's see. So the first one was we have 1, 2, 3 as the first one. So we have 1, 2, 3. Let's write that so that people can see 1, 2, 3. The first, we can maintain this as the first one. Then the second one, we can also have 1, 3, 2. So 1, 3, 2. 1, 3, 2. Then we can also have 2, 3, 1. Oh, okay, 2, 3, 1. Then we can have 2, 1, 3. Would that be correct? 2, 1, 3. Then we can also have what? 3, 1, 2. 3, 1, 2. Three, 1, 2. Is that all?
3, 2, 1.
3, 2, 1. Then yes, and 3, 2, 1. Then we are almost there. And 3, 2, 1. So let's count them and see 1, 2, 3, 4, 5, 6. So here order is important. So there are 6 different ways that we can arrange the digits 1, 2, 3 in order. Any question?
Hello, sir.
Yes.
Hello, sir.
Sir, please. Yeah, your hand.
Sir, please. So the order means that when 1 starts, it finishes. Then 2 will start, it finishes before 3 will start and it finishes. Hello.
Yes.
Sir, the 1, 2, 3 arrangement.
Yes.
I'm saying that means if you start with the first one, which is 1, 1 finishes before you go for the 2. It also finishes before the 3. That is the order, right?
Yes, yes. So here,
okay.
2, 1, 3 is different from 1, 3, 2.
Yes, sir.
But if it is combination, that one, they are the same. 3, 1, 2, 313 will not be repeated again. But so like we could repeat. We have 213, then we have 312. Yes. So this is where we have the permutation, right?
Hello, sir.
Yes.
Sir, please, the 231 and the 213. I think the 213 should come before the 321.
This one, yes, because we were doing it, that's why it happened that way. Do you get it? But
yes,
when
sir.
you are, yes, because I was doing it.
Yeah, the 213 should come before the 2.
Yes. What matters is that the order is different. That's what we want to say here, because order matters. So you have 1, 2, 3. Then you can also have 1, 3, 2. Okay, 1, 3, 2. You can have 2, 1, 3. You can have 3, 2, 1, and so forth. Do you get it? It's the order. Okay. They should not be the same. That's what we are saying.
Thank you.
So when we have a number like for this one, sitting arrangement. So we have the round table arrangements. Okay, if you want to arrange your guests around a round table for a dinner, the formula is n-1 all factorial. That's the formula. So if there are 8 guests and you want to arrange them, okay, you want to arrange them on a round table. Arrangement on a round table, that's what we are saying here, not on a bench. You see the bench is linear. That is what we have done. Okay, the bench, that is where we have the n factorial. But here we are looking at a round table. If it's a round table, the formula is n-1 factorial. So if there are 10 people and you are arranging them on a round table, then it will be 10-1 factorial. And that will give you what? 9 factorial. And the 9 factorial is 9 times 8 times what? 7 times 5 times what? 4 times 3 times 1. So then you have to use your calculator and do computation. So please, you need calculator for the statistics. I'll be surprised you go to the exam hall without a calculator. You'll be hot.
Yes,
that day you'll be hot. When you finish, add the number of ways so that you will not be marked wrong. Okay, whatever you get, ways. Ask the number of ways. So that is what we have here. That if we have 8 guests, then the number of ways to sit them are around a round table can be what? n-1 factorial, which is, please calculate that and see if you get the 5. If you get the 5,040 ways. We are not adding the ways, but you should add it, okay? They are not adding. Is it correct?
Yes, please.
Okay. Any lady to confirm? Where are my ladies? Lizzie, are you here today?
Hello, sir.
I'm asking of Lizzie. Are you Lizzie? Lizzie, are you sure you are the one?
Oh, sir, it's me, Elizabeth Opon.
Elizabeth. Okay, Elizabeth Opon. Okay. Hey, Lizzie, this is the second lecture you are attending. No, this is the first. I think this is the first lecture, right?
No, the first one I was there.
Online.
Madam, 7 to 11. I was there. Yeah.
Hey. All right. You are welcome. Because of me, try and become in.
Yes, sir.
Yeah, because when you pass, you know you are passing for me. Please pass for me.
I know, sir.
Okay, so we go. So somebody was asking a question. Can we listen to the person?
Yes, so sir, the answer is 362880. But you're saying 5 something.
What is here? 7 factorial. What did
No,
you
that
get?
one is the 9 factorial. This one is 7 factorial.
Oh, I'm talking about the 7 factorial. Okay. The one here, the one you have in your slides here.
Actually, we can't see it well, so it's like, yeah.
And that one was you are arranging 8 people. This one, can you see? Can you now see?
Yes, please.
Yes, please.
For a dinner party with 8 guests, the number of ways you can arrange them around a round table is n-1 or factorial. So that would result to what? 7 factorial.
50,
40. And 7 factorial, I think, is correct. And
yes,
it's an application. It's an application of permutation. Okay. Can we move on?
Yes, please.
Yes, please.
The next thing is combination. Combinations. So combination, yes. Can you tell me something about combination before we move on? What is unique about combination? How is combination different from permutation?
Please, this one combination, we said order of arrangement does not matter.
Is that Abigail?
Yes, sir.
Oh, Abby, my TA. Abby, is Abigail right? Do you agree with her?
Yes, please.
Okay, so in combination, order does not matter. If order does not matter, then let's see how many ways we can combine apples, bananas, cherries, right? Grapes and orange. Let me do it well so that you people can do that for me. Oh, I'm coming. I want it to be a bit bigger. Okay, I think the one I wanted to show, we have left that play, no problem. So we are forming teams from a class of 10 students. So how many students are there?
10.
10. Then where only 4 students can be selected for the projects. In that case, we are selecting any 4. So it will be 10 combination word 4. That will be 10 combination 4. Okay? 10 combination 4. And please write the combination word. So if we have the n was 10 and we are choosing which is our r, the r is what you are choosing. If you are choosing 4, then it means that n combination r will now be equal to what? Will now be equal to, I remember we said it's n factorial divided by n minus r factorial, r factorial. Do you remember that?
Yes, please.
Then when we continue, it means we are going to have the n combination r to be equal to what? 10 factorial divided by what?
10 minus 4 factorial.
10 minus 4, then 4 what? Factorial. 10 minus 4 factorial times 4 factorial. So that is going to give us 10 factorial divided by 6 factorial times 4 factorial. The simple way to do this is to do it as 10 times 9 times 8 times 7 times 6 factorial, all divided by the 6 factorial times 4 factorial. So this 6 factorial would divide this 6 factorial 1, right? Right?
Yes.
Then you can continue by saying that this will be the same as 10 times 9 times what? 8 times 7 divided by what? 4 times 3 times what?
2
times 2
1.
times 1. And this one too, you can start doing your simplification. 4 and 2 would divide the 8. Now it is left with 3. 3 will divide itself 1, divides 9. How many times? 3.
3.
Now you'll be left with 10 times 3 times what?
7.
7. And that is 70 times 3. What happened there? Yes. So that is that. So that's so the 210 you write 210 ways. Okay, 210 ways. So 210 ways. Please use the calculator straight away and let's see. 10 combination 4. What do you get?
So 210.
Okay. 210. Now we come to a basket containing, let's look at this example and see if you can do it for me. You have the basket which contains apples, bananas, cherries, grapes, and orange. Choosing 3 fruits can result in combinations like what? Apple, banana, cherry, apple, grape, orange, and so forth. But computing this, look for the number of what? The number of ways you can do that. How many fruits are involved? How many fruits are we looking at? 5. How many are we choosing?
3 at a time.
3 at a time. So that would be 5 combination what?
3.
5 combination 3. So you just do that, and then you'll see the total number of ways.
And that's 10 ways.
That is what? 10 ways,
Yes.
Okay. That's 10 ways. So 5 factorial divided by 2 factorial times 3 factorial. Let's see if it is true. So that is 5 times 4 times 3 factorial divided by the 2 times 3 factorial. So this and this goes. So it's 10. Okay, 10 ways. Always remember to add the ways. Remember to add the ways. Then you also have a similar one is this pizza from a choice of 8 options. So how many pizzas do we have? We have the pizza, we have the choice of 8 mushrooms. You have been eating this in a pepperoni, right? Olives. Madam Aduma.
Yes, Doc.
I mentioned that this in the options, and let me see. Mona ya mo pizza. Man mo pizza. Oh, you don't like it? You don't like it? I know you don't.
No, I should mention which options.
This one, the names of the options we have, e.g., mushrooms.
Mushroom.
The next one is what?
Pepperoni.
Do you people know the pepperoni? The ladies. Remember the pepperoni. I have not even heard it before.
Dog, we don't like it too.
Hey. You are a suspect. But what we want to say here is that we have 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. And they are saying that we want to allow only 3 combinations at a time. So you have to choose 3 at a time. So that will be 8 combination 3. How many different ways can that be done? Tell us. How many different ways can that be done?
56.
56 ways. When we are done, we are almost done. The last example I want you to work on, then we go, is this one. You have the letter A, B, C, D. I think it's this one, yes. You have the letter A, B, C, D. How many ways can... You said permutations are arranged of objects where the sequence is important. For instance, arranging the letters A, B, C can lead to different sequence. Okay, then when we come to combination, Okay, so the first one is permutation. Okay. Now, the question I want to ask you before we close, I'm coming to end the lecture. The question I want to ask you is that when it comes to lotto, gambling, please, can you hear me?
Yes,
Yes,
please.
sir.
Those of you have been staking lotto. The ladies are even far doing better in staking lotto than the men. The lotto, is it permutation of numbers or is combination of numbers? Is the lotto forecaster right to say that
Permutation.
what the lotto forecasters are doing? Are they doing permutation or they are doing combination?
Permutations.
Permutation.
There's combination.
Are they doing permutation or combination?
There's combination.
Then maybe
The correct answer. The correct
Combination.
no.
Combination.
The correct answer is combination. Go and
Yeah.
find out.
Combination.
They are doing
They didn't consider
combination,
the other.
Then you
and they
choose
always
one.
say
they name it
permutation.
pen.
Pen for me. Pen for me. It's combination.
It's combination.
Now, this is my advice for those of you who have mistaken lotto. This is 2026. This is 2026. That's use the idea of combination to enhance your understanding in statistics and your student understanding in statistics. Okay, and avoid doing the permutation. Any question before we draw the curtain to the end? I think you have the slides. You go and read. We have, this ends the unit 4. In our next meeting, we'll be discussing unit 5 and 6. Any question? Otherwise,
So, sir,
yeah.
because the order does not matter in lotto staking, that is why they are using the combination, right?
Yes.
Wow. Okay.
And what they are doing, order does not matter.
Yeah,
They
order
just
does not
combine
matter.
the numbers. They are not permit. Okay.
Sir,
Any other?
sir,
Yes.
sir, please. I found that the n combination R can also be written as n permutation R over R factorial.
It's true. So let's write that one down, but don't go for it anyway. But let's write it down. So let me write it here so that people, yes, it's true. N combination R is the same as n permutation R divided by what?
R factorial.
Now let's simplify this and see if it will be true. Let's see something. So we know that the n permutation R is the same as n factorial divided by n minus R factorial. Is that not it? So
Yes,
putting that back gives you n factorial divided by n minus R factorial, all divided by R factorial. So at the end of it all, this is the same as n factorial divided by n minus R factorial times, is that not what you have been saying? Times 1 divided by what? R factorial, isn't it?
Yes, please.
So that now brings it as n factorial divided by n minus R factorial times R factorial. Is it not true? So it's true.
Yes.
So the proof, this is true. Okay, this and these are equivalent. They are true. Is it okay? Are you okay?
Yes, please.
So that is it. Any other? Or we are drawing the curtain to an end. But before, Madam Aduma has a message for you. So I think she wants to give you. Yes. Do you have any question? Otherwise, we listen to Madam Aduma, then we call it.
Sir.
Yes. Oh, please
Yeah, I think
talk.
someone wants to talk.
And the person should talk. Look, my fufu is
Hello, sir.
talk.
Sir, please, can you,
Go back to where?
hello, sir. I said that. I said, can you go back to the last question that we saw? I want to take a snapshot so that I will look at something later.
Which
Where we have
last question? You cry.
the
This one. Wait, let me see. Was there something on this line?
no, sir. Please.
This one. Was it
No,
this?
sir.
Not this one. This one. Was it this one? Oh.
No, sir.
This one. Okay.
No, sir.
Let me
go
narrow
forward.
it. Yeah, let me narrow it a little bit so that you can. Oh, yeah. So you can have it this way.
Sir, please, not this one.
Not this
no,
one.
the one after this. Yes, sir. Go forward.
This one. After.
Sir, move forward.
Forward, this way. You pay me for what you are costing me.
As the one I can't pay you.
You pay me. You will not see me. Which one?
Yes,
Yeah.
sir, it's okay. It's okay. Yes.
Is it this one?
Yes, so sir.
So n combination R is equal to n permutation R divided by R factorial. But the n permutation R is the same as n factorial divided by n minus R all factorial. Now, putting that or replacing that with n permutation R will now give you n factorial divided by n minus R all factorial, all divided by R factorial. So when you simplify, you clearly see that you are getting n combination R is the same as n factorial, is the same as n. So you see that these two are the same. What we have, not this two. This is not. This and this are the same, but yes. So that is that. Please, on that note, listen to Madam Aduma. Do you have message for them? Do so because me, I'm going. Or I can even leave, isn't it?
Okay. Yes, please.
I can leave.
If you want to, Doc.
Yeah, so me, I'm going. See you all.
Thank you.
Happy New Year.
Okay, sir. Same to you.
When you are eating your fufu, remember me. Bye-bye.
Hello, class.
Hello.
Yeah, so I was thinking that I've missed you.
Madam Vivian.
Yes.
When we come for face to face, we don't see you.
You see me. You see me.
I want to see you. I want to see you.
Those last 2 weeks I had traveled, so I wasn't around.
Okay.
This time I'm praying that you see me. So what I have to say is that, after the next week face to face, and I think the practicals week, we are not meeting again. Then you are starting. Am I lying?
Yes, please.
Okay, so I wanted us to meet maybe during the week, maybe one evening or dawn. What do you think? So that at least we can, because some of the slides
dawn is okay.
7. Dawn is okay.
Yes.
Okay,
dawn is okay.
I'll talk to Doc and I'll give you the day. It may be a Wednesday or a Thursday.
Okay.
So we'll communicate on the platform. Okay.
Okay. Madam.
Then the assignment that has been given to you, please take it serious.
Okay.
Don't let someone photocopy and give it to you. Do it yourself if you don't understand, because these are the questions that come in the exams.
Okay.
Please try your hands. At least try your hands on them and be well versed in them, so that the exams you can write well. Okay.
Okay.
Hello, madam.
Yes.
Please, will we be drawing graphs
in the exams? No.
Yes, please.
Okay. No.
Okay.
No, you don't. I've never seen.
I was thinking I'm seeing a lot of diagrams, so I was thinking.
Yeah, the diagrams are there for you to understand and be able to teach at the SHS level.
Okay. That's
but so far, with the past questions I've seen, I've never seen a student drawing graph in the class. during exams.
Yes,
But I'll
please.
still talk to Doc and I'll get back to you
Yes,
on
please.
the platform. I'll confirm that
Okay.
on the platform.
So, madam, the dawn is
Thank you.
okay.
Done, it's okay. Okay, so
Yes.
I'll talk to
That is
Doc
Sometimes
and
during the
we'll
day,
see.
the network. Sometimes
Yeah,
during the day,
it's
the
true.
network
The network
is
is
not
poor.
something.
Yeah, I understand.
Thank
So
you.
Madam,
I'll talk to Doc.
Madam, please.
Yes,
Madam, please, since you've talked about past questions, can we
I should
get
get
any
you some.
sample to know how the questions?
Okay,
Yeah.
I'll try and get you some.
okay.
I'll
Please,
consult.
are we
Thank
meeting
you.
at dawn?
I'll
Thank
consult
you.
some few people and get you some. Okay.
Thank you, Madam.
Confirm,
Thank
are we
you.
You're
meeting this
welcome.
dawn?
Tomorrow, yes. Tomorrow is Sunday. Yes. Yes, please. We are
So we are
meeting at
meeting
dawn.
dawn.
Our class will be
Okay,
shifted to dawn
4.
at
okay,
4.
okay. 4
I
to
think
6,
that one
right?
too is
Okay.
an important information I needed to let you know. So
4 to
tomorrow
6,
we
Okay.
are
right?
Madam,
meeting
we do
at
on
dawn.
statistics. Madam, we do on statistics.
No, no,
We
no,
are
not
doing
statistics.
algebra, advanced algebra.
Thank you.
Tomorrow dawn, 4 o'clock. Please let's all try and attend. And one more thing.
Okay.
One more thing. UCCA, they are taking attendance too. So some of you who do not like attending online lectures, let's be careful because they take um, the register of those who attend and those who do not attend. So they keep records of that, and those things really matter. They really matter because attendance also forms part of your grading. So it's not like only assignments, quiz, and exams. Your presence in the classroom also matters. The UCC, we have people that have been assigned that log in during online class. They log in and they take the names of people who came. So please tell your colleagues and tell them that they should be attending online class. It's very important. Okay.
Okay.
So thank you very much.
Okay, madam.
By God's grace, we will meet tomorrow dawn.
Okay.
Okay. Have a nice day.
Thank you.
Same to you.
There is a lady, there is a girl lady on the platform.
And the one talking you mean you are again.
Hey, in what check?
Oh, fine,
Tete.
oh, fine,
I mean, Soliaka next week, we're back face to face. Oh, no.
oh, fine.
Yeah, you want to tell you. Okay, bye bye.